Okay, so here's the first part of homework 2-1. Hopefully you get through about the first half or so. So which of the following is an accurate statement? The magnitude of a vector can be 0 even though one of the components is not 0. Well, the only way a vector can be 0 is if both the x and the y components are individually equal to 0, right? If you think about that, if you had one of these 0 and the other one wasn't 0, then the magnitude of that whole vector would just be whatever the other one was. So in this case, that is not true. It is possible to add a scalar and a vector. That's also false. You can multiply a scalar by a vector, so if I take 5 times the velocity, right, I can do that, and I would just distribute that 5 to each of the components, but I can't add them. I can't sum those two quantities unless they're both vectors. Even though two vectors have unequal magnitudes, it is possible that their vector sum is 0. Again, if they're unequal magnitudes, if they're unequal vectors, the only way that they could sum to be 0 would be if they canceled out both components, but in order for that to happen, they'd have to have equal magnitudes, so that doesn't make any sense. Rotating a vector about an axis passing through the tip of the vector does not change it. That's also false, right? We know that a vector, the magnitude and the direction are important for that. And so if I take a vector and I rotate it, that's no longer the same direction. So that's false. And then option E is my best answer here. The magnitude of a vector is independent of the coordinate system used. So what that's saying is if I've got my coordinate system, if I take a vector and I place it right at the origin and it goes off this direction, that would be, whatever magnitude. So maybe if I go over 4 and I go up 3, that would have a magnitude of 5, right? The length of the hypotenuse. It doesn't truly matter, though, where that vector is located. If I took that vector and I moved it up here, right, even though it's somewhere different in that coordinate system, the magnitude would still be 5. So regardless of where the vector is placed, the magnitude is always going to be the same. It doesn't have to be oriented at the origin. It could be oriented wherever we want it to be. The vector itself is independent of the coordinate system used for reference. So anyway, question 1, make sure you're pretty comfortable with those basic concepts. Question 2 goes back more to just kind of the computational side of vectors. So under what condition, and these absolute values, those are representing the magnitude then of this sum. Okay, so under what conditions would the magnitude of vector A minus B equal A plus B? Well, the only time that this is going to happen, because I'm doing minus B, would be if I was in opposite directions, right? Because obviously if they were in opposite directions, right, if I take vector A this way and then vector B going this way, ordinarily those two vectors, the magnitudes would cancel out. But in this case, if I subtract them, right, if I subtract vector B from A, then I'm actually reversing that direction, and so I'd be tacking that magnitude on. So the only time that this is going to be true, the only time we're going to have the magnitude of A plus B equal to the difference between those two vectors is if they are in opposite direction. So maybe a trickier one again, but hopefully you kind of take your time ruling out the other options and see that that one is the best answer for us. Question 3 here is a pretty basic vector calculation problem, right? So you initially walk north 55 meters, and then from that location you turn to your right 60 degrees. So instead of going due north, I'm going to turn right 60 degrees, so I'll put in that point of reference. So instead of going due north, I now turn to my right 60 degrees. And then I walk an additional 45 meters. How far are you from where you originally started? So we're looking for our displacement, right? We know displacement is a vector quantity, and so the only way I can do this, the easiest way to do this, is to break up my second vector into components. So I know that this first one goes straight 55 meters to the north. The next vector here, right, my next vector goes over and up. So then my next vector, if I can find those two components, no big deal. So this would be 30-degree angle, right? So finding the cosine component here of 45 and then finding the, of 30 degrees is what that should have been. So finding 45 times the cosine of 30 degrees and then 45 times the sine of 30 degrees. Right, obviously just calculate those. We get the cosine component to be about 39. It's about 38.95, I think. So about 39. And then the sine component would just be half of that 45. So then that tells me that my horizontal component for the second vector is 39, and my vertical component for the second vector is 22.5. right? So then if I total the distances, if I total my displacements rather, I just simply add the vertical components and I add the horizontal components, which in this case I only have one, right? So vertically, my total vertical motion would be 55 meters plus 22.5, right? So 77.5 meters north is my vertical motion, and then my horizontal motion, my total horizontal, again, I didn't have any horizontal movement from the original vector there, but I did have 39 meters to the east, it looks like. So 39 would be my total horizontal component. So then I just use those to build my final triangle here, or really just my final distance, right? So I'm looking for what's that distance here. So if I'm looking for that distance, I know that I've gone horizontally 39, and I've gone vertically 77.5. So I've got those two measurements to work with, and then I just have to calculate my hypotenuse. Now in this case, they just asked me how far, so I don't even particularly care about the angle, right? So quick Pythagorean theorem on that. If I do a quick Pythagorean theorem, I found out that that distance there would be about 86.8. So my hypotenuse, my distance would be 86.8 meters from where I started to where I ended. And again, you don't necessarily need the angle. If you did find it, it would be north 26.7 degrees east. But this one just asked me how far it went, so I didn't really need that vector. Anyway, hopefully this one wasn't too bad, just a review of what we've seen so far. Okay, question 4 here is also hopefully pretty straightforward. You do need to be careful though about what we're actually finding. We're looking for vector C, which is not just the net vector from these. We're actually taking vector B and subtracting vector A from it. So again, we're not just summing these together, we're actually finding the difference between those two. So all I really have to do though is find the components of each one of these and then subtract the components. So rather than add the components, I'm just going to subtract them. So if you want to check your answer, just ask for the magnitude. The correct answer should be about 16.2. So if you got that and you're confident, feel free to jump ahead in the video. If not, I will work that out. Okay, so I want to find my vertical and my horizontal components for both A and B. So I'll call that AY and AX, right? And I'm going to use kind of vector notation using the brackets and such. So if I'm looking for the components of vector A, well, my horizontal component, my X component, would come from the magnitude, which they told me was 16, and I'm going to make it a negative 16 since I know that it's going off to the left. And then it'd be the sine component of 42 degrees. So if I used 48 degrees, it would be cosine, but if I used the 42 degrees, it would be the sine component of 42 degrees, because that would find me my opposite side, right? And then I'd do the same type of thing for my vertical component. Now I'm going to leave this one as a positive because I am going north and not left or down. So I'll leave that as a positive, and then it'd be 16 times cosine of 42 degrees, right? So setting that up, finding those two components, I would find that to be, so if I'm leaving it in bracket form here, it'd be negative 10.71, comma, and then 11.89. So that gives me my two components of vector A. Now you could also write this as negative 10.71, that I with a hat over it, and then plus 11.89j. So just get comfortable with the various forms that we could use to represent this, right? I know last year we typically just defined it as AX equals yada yada yada, and then AY equals whatever, right? But in this case you can do any of those formats, whichever one you're comfortable with. But anyway, do the same thing for vector B, right? So vector B goes over and down. Again, if I want to find those two components, I just need to break it up. So for my two components, vector B would be the magnitude, which is 7. It is again going off to the left here, so I'm once again going to make that a negative. So it'd be negative 7 times cosine of 31, and this time I'm using cosine based on that angle, right? And then it'd be, because it's going down, it'd be negative 7 and then sine of 31. Right. So just calculating these two measurements, again, very similar to what I did for A, I get about negative 6, and then I get about negative 3.61. And again, keep in mind that if you wanted to use this in terms of I and J, it would simply be negative 6I minus 3.61J. Right. So be comfortable with both of those formats. So then in this case, to find my resultant vector, to find my magnitude at least, for C, all I have to do is take vector B and subtract A. So if I want to find C, I'm just going to do B minus A, and because I found the components, I'm just going to do that component by component. So what I mean by that is I will do, so I may even just use the I and J format down here. What I will do, negative 6I minus 3.61J minus the entire vector for A, so minus negative 10.71 I plus 11.89J. So I've got those two vectors set up, I'm subtracting them, and that is the biggest key, is making sure we're not accidentally adding them, but we are in fact subtracting them. So then my components for vector C, I just combine like terms, right? So I distribute the negative, I combine like terms, and I get my components for C to be 4.71 I, and then minus 15.5J. Now keep in mind, this is not my answer yet. They do want me to find the magnitude, and really all this tells me is that my components, right? It tells me my net components when I do B minus A would be 4.71 to the right, and then negative 15.5 down. So if I want to find the magnitude of C, I just have to do the Pythagorean theorem using those two vectors, those two components. So I just do the Pythagorean theorem of 4.71 squared plus 15.5 squared, and keep in mind it doesn't really matter if it's a plus or a minus at this point because I'm squaring that quantity, right? And so that's where I get my magnitude to be 16.2. Okay, so 16.2 units. They did not tell us we had to find the direction, so I am not worried about finding the direction. I just want to know the magnitude. And pause for a second, make sure this approach makes sense, right? If I took B and then subtracted A from it, I would subtract A, which would mean I'm moving back this direction, right? So I do end up going to the right, which is why I went a positive 4.71, but I definitely also go down quite a ways too, which is why it's a negative 15.5. So make sure this is all kind of sinking in as you do it, but hopefully this was a pretty easy question. So then question 5 here is probably the last question we'll get in this first part of homework 2-1. And the biggest thing to watch out for maybe is the 2% grade does not mean it's an angle of 2 degrees. I know the first time I looked at this I started to make that a 2-degree angle. Right? The 2% grade tells me that the rise is 2% of the run. And so basically what I did was I just said if I rise 2, that meant I ran 100, right? Because 2 would be 2% of 100. What that does allow me to do though is to find my angle, right? So I can find theta as simply the tangent inverse of 2 over 100, or 1 over 50 if you prefer. But anyway, when I find that angle, it's actually a little bit less than 2 degrees. It should be about 1.15 degrees. And so that's important because they tell me then, so the helicopter is flying horizontally towards the hill, so the helicopter is flying this way towards the hill. They want to know which component of that velocity is perpendicular to the slope. Well, the biggest thing in actually breaking this problem up, so here's my 444, right? That's the actual velocity, so this should be the hypotenuse of the triangle. So if I want to break that up, I want to break that up into a right triangle such that part of that right triangle is parallel to the hill, and part of that right triangle is perpendicular to the hill. Okay, and keep in mind this would be my right angle down here. So again, I know the hypotenuse is 444. Obviously this triangle is greatly exaggerated because this angle is only 1.15 degrees, and in fact this angle would also be 1.15 degrees. So I've got this triangle set up. They want me to find the component of my velocity perpendicular to the hill. Well, that just means I need to find this piece right of the velocity. So once you get the setup of this problem, really not too bad. If I want to find that component, that would just be the sine component, right? So I'd say 444 times the sine of 1.15 degrees, and obviously it's going to be a very small number since the sine of 1.15 is such a small quantity, right? So anyway, this would be the component perpendicular to the hill, and I end up getting about 8.9 meters per second. So of the 444 meters per second, about 8.9 meters per second would be my velocity perpendicular to that hill. So anyway, hopefully this question wasn't too bad, right? Again, making sure you get it set up is probably, hopefully, the biggest piece for you. But anyway, we'll pick up the last 3 questions then in part 2 of this video.